So it's Leetcode problem 377, combination sum 4. So we are given an array of positive numbers and one target number. So our task is to find how many different ways we can make the target sum using the number from the array. Okay, we can use the same number many times, and the important thing is that order matter. Okay, that means if we use the same numbers in different order, it is counted as a different ways. Okay, so we only count the way where the total sum became exactly equal to the target. So see what is, let's understand. For example, we have x equal to 1 2 3 and target is 4. Okay, some, let's make some possible ways. What 1 place 1 place 1 place 1 is 4. The one way. Next way is 1 place 1 2 place 2, two way. Next is, what can we make, 1 place 2 place 1 2 place 1 place 1 and 2 place 2 1 place 3 3 place 1. So there are 1 2 3 4 5 6 7. So there are 7 ways. Okay, so the total numbers of ways are 7. So there are 7. So the total number of ways is 7. Okay, so we need to count how many ordered combination can make the target sum. If we have these numbers 1 2 and target is 3, first is 1 plus 1 plus 1, it was 3, 1 plus 2 3, 2 plus 1 3. So total ways are 3. Okay, so there are total ways are 3. Okay, next we have target like 2 and 5. No, let's make easy numbers. Okay, if we have target 2 and 3 and target is 5, so 2 plus 3 and 3 plus 2, there are 2 ways, so the answer is 2. We just try all possible ways to make the target number and count how many correct way we get. Okay, next let's solve this in recursion. So we start from target. Okay, we start from the target number. Every time we try to subtract one number from the list, then we again solve the small problem. Like see, if we have, now we have nums of array 1 and 2, target is 3. See, left side we target -1, in right side target -2. So the valid ways, total valid ways in 0. No ways are, no, there was 0. So if we come negative, we stop. Okay, we get negative number, so then we will stop. Let's make a tree. We have tree like this. 3, we have two options. 3 minus 1, this target -1 is 2. Okay, next to have both. Next is 3 minus 2, 1. So 1 and 2, this one. Okay, next 2 minus 1 is 1. So 2 minus 2 is 0. So we have two options, 1 this one. Okay, so 1 minus 1 is 0, 1 minus 2 is -1. So here we stop, because if case come negative, we stop. Here we get 0, 1 minus 1 is 0, so the one valid way. In this case 1 minus 1 is 0, so here 0. 1 minus 2, it's -1, so it was -1, so it here will stop. Okay, so see, left are -1 and right -2. if we get 0, it was valid way. If we get negative, so here we stop. Okay, so there are zeros. How many zero we get? 1 2 3. So 1 plus 1 plus 1 and 1 plus 2 and 2 plus 1, 2 plus 1. Okay, so see, 1 0 1 0 1 0, so we get 3 zeros. So the answer is 3. Okay, there are 3 ways. Let's take another example. If we have nums of array like 1 and 3, target is 4. We have 2. 4 minus 1 is 3. Okay, here we have 2, and next is 4 minus 3 is 1. We have 2. Next, 3 minus 1 is 2, and 3 minus 3 is 0. We have 0. Here we have two options. 2 minus 1 is 1. 2 minus 3 is negative 1. It was negative 1. Here we stop. Next, 1 minus 1 is 0, and here 1 minus 3 is negative 2. Here we stop. 0, it comes 0. 1 2 0 we get. And here see, 1 minus 1 is 0. It was 0, and 1 minus 3 is negative 2, so the answer is negative 2. So there are 0 0 0. So there are total 3 ways, like 1 plus 1 plus 1 plus 1. Next is 1 plus 3 and 3 plus 1. So there are 3 ways. The answer is 3. If we have example, see, let's make another tree. Nums we have 2 and 3. Target is 5. 5. We have two options. 5 minus 2 is 3. Okay, and 5 minus 3 is 2. Next, 3 minus 2 is 1, and 3 minus 3 is 0. So here 0. Next, 2 minus 2 is 0. It was 0. Next, 2 minus 3 is negative 1. So here we stop. It was negative 1. Next, 1 now. 1 minus 2 is negative 1 and negative 2. 1 minus 3 is negative 2. So it was negative 2. It was negative 1. So here we stop. So there are total 2 ways. Okay, there are 2 ways. 2 plus 3 and 3 plus 2. 5 5. So there are 2 ways. Let's take one more example. If we have 1 2, target is 2. Okay, 2 minus 1 is 1, and 1 minus 1 is 0, and 1 minus 2 is negative 1. So here we are going to return 0, 1 valid way, and here we are going to stop because it was negative case. And 2 minus 2 is 0. Here we are going to return, see, 1, and this is 1. So 1, it's sent 0, it's sent 1. 1 plus 1 is 2. So there are total 2 ways. Okay, so see, if we have, let's take another example, another number. See, nums is equal to 1 and 2, and target is 3. So the problem is count how many different ways we can make 3. Okay, so first is 1 plus 1 plus 1, 1 plus 2, and 2 plus 1. So there are 3 ways. Okay, so the answer is 3. First, we need a function that return number of ways to make a target. So we write function. So we write a function int solve vector int and nums target. Okay, This function solve one target problem. Okay, next see, if target becomes 0, okay, if target becomes 0, okay, if target becomes 0, like 3 2 1 0, so we found one valid way. If target becomes 0, then we have found one valid way. Okay, so write base case. If target is equal to 0, return 1. We have found one valid way, so one current combination we have found it. Okay, next, if target become negative, see, if target become negative, 3 1, it's negative 1, so see, in this case it has become negative, and 1 minus 2, it's negative 1. If target become negative, if update goes below 0, okay, if update go below 0, negative 1, negative 2, okay, so this path is wrong. So if target is less than 0, next base case is what? If target is less than 0, return 0. Okay, so no valid way. So we need a variable of count total ways. So int ways is equal to 0 to add all valid answer. Okay, so to add all valid answer, if see, where is that number? So at every step we try each number. Okay, so at every step we try each number. So we write this function for int num is to nums. Every number is a possible choice. Okay, like see, if target is 3, we choose 1, so new target becomes 2. If we choose 2, so new target become 1. Okay, so next what we do, ways plus equal to solve of nums, target minus num. Okay, so this will solve smaller problem and add way. Okay, after checking all numbers, we just going to return way, return ways. Okay, this was a base case. Next base case, if variable in found variable, we just return solve of base. I think it was right. Target, we have taken base case, so let's convert this code in map, and we have to return not ways, we have written nums and target. See, start from target, try every number, reduce target, and if target becomes 0, one way and always. Okay, recursion works correctly, but it becomes very slow because it's repeat the same work many times. So for this we are going to use memoization. What memo will do, it will store the answer so we do not solve the same problem again. Okay, so see, if we have numbers like this, if we have number like this 1 2 and target is 4, so solve of 4, solve of 3, solve of 2, solve of 3, it's come again, and solve of 2 has also come again. So recursion repeat the same target many times. So when we solve, so what memo does, when we solve a target once, we store in memory. Okay, like memo of 2 is 2, memo of 3 is 3. So next time we need solve of 2, we directly return memo of 2. Okay, if we need solve of 3, we just directly return this memo of 3, direct return memo of 3. So there was no recalculation. See, without memo how it's look, solve of this function as, so solve of 3, solve of 2, solve of 1, and next solve of 2. So it was repeated. Okay, if we it was recursion, pure recursion, and it was memo. In memo how, solve of 4, solve of 3, solve of 2, it was stored, we store this. If solve of 1 comes, it will also store. If we call solve of 2, we return directly, it was written from here. Okay, so we store answer of solve problem, so we do not repeat same work. Okay, so see, recursion repeats same targets again and again. So what we are going to do, we are just store answer in map. So how we always we implement memo in map only. Okay, we need a map to store answer for each target, so we create a map unordered int memo. Okay, so it's mean, see, it's mean what map give as key and value. Okay, map give this both. Okay, key means target, value means number of ways. Okay, number of ways. If memo of 2, say memo of 2, there are 2 ways, memo of 3, so there are 3 ways. Okay, next, so say it was same recursion function, but now we use memo. Okay, so it was base case also same. See, before solving, if we want to check, it was already solved this target. Okay, if memo dot count target return memo of target. Okay, if answer already stored, return directly. That's only. Okay, next, see, we have save answer, so we do not recalculate it again. So okay, where is the int where, for memo it will saw, and instead of returning we just control memo of target is equal to base. So we just return base. Yes, see, memo is just recursion plus memory. Before solving, just check memory. After solving, store answer. That's it. So memorization is not wrong, but it is not always the best choice. Okay, see, in simple words, memo is correct and works, but sometimes DP tabulation is better. Okay, so what is tabulation means? So what is tabulation? Okay, so tabulation means solving small target first and building the answer step by step by using DP array. Okay, so we fill answer from 0 to target. If we have number 1 and 2, target is 4. Okay, so count how many ways to make 4, so that this is a goal our. Okay, first we need an array to store ways of every target. Okay, first we need an array to store the target of. Okay, we need an array to store ways of every target. First we create a vector dp vector vector of dp target place 1 initializing with 0. Okay, so dp of I is number of ways to make I. Okay, like how it was filling. So see, dp of 0, dp of 1, dp of 2, dp of 3 and dp of 4. Okay, so there is only one way to make target 0, so choose nothing. So base case will be dp of 0 is equal to 1. Okay, so we build answer from small target to big number. For int I is equal to 1, I is less than or equal to target, and I plus plus. See what, first we solve 1, then 2, then 3, then 4. Okay, for every target try each number. No, we need to try each number for every target. So for int num is to nums. Okay, if we use a number, we look at smaller target. Okay, if I minus num is greater than or equal to 0, dp of I plus or equal to dp of I minus num. Okay, so way to make I is equal to way to make I minus num. So see, let's make a small trial. So here we are going to initialize dp array with I target place 1. Target place 1 means, so the target is, what is the target? Target is 4. See, target is 4. Yes, target is 4. 4 plus 1 is 5. So we create an array of dp of array with 5 number. Dp of 1 0 0 0 0. 1 2 3 4 5. So this is a base case, 1 is the base case. So we are initializing with zeros. Okay, we create an dpr vector and we have filled with 0. So the value is 0. Okay, if I is equal to 1 and number was 1, now what is the number 1 and 2 now? So we have number 1 and 2, so the number I is equal to 0 1. We start from 1 only. So see what it was happening. dp of 1 place equal to dp of 0, so it was 1. So num2 will escape, so it's become 1. Okay, it's become 1. Next I is 2, number is 1, I become 2 and num is 1, so dp of 2 plus or equal to dp of 1, so it was 1. So it was 1, so 1 now. Next is num2 plus num2 and dp of 2 dp of 2 plus or equal to dp of 0, so it was 2. So next 2 1 plus 1 is 2, so it's become 2. Next is I is 3, I become 3, num is 1, so dp of 3 plus equal to dp of 2, so it was 2. 1 2 3, it was 2, and dp of 3 plus dp of 1, so it was 3. Okay, it was 3, so it's become 3. Okay, dp of I is equal to 4, so dp of 4 plus equal to dp of 3, so it was 3, and dp of 4 plus equal to dp of 2, it was 5. So it's become 0 become 5. So next see, dp of 4 is 5. dp of 4 is 5. So let's complete the code. First we have create with dpRA. This was a base case and this is a row for a number n, if dp of I, if dp of. So next we are just going to return dp of target. Just return dp of target. So see, recursion goes top to down, tabulation goes bottom up using a dpRA. Okay, so let's submit the code. It was wrong. Oh, why? What happened? dp of I plus I minus none. Or it was stirring. What happened? We have created times sign integer overflow int. Let's check the code. First we have created dp vector plus 1 initializing with 0 dp less than or equal to target I plus square if if I minus number to 0, if I have not written this case, if I minus I have written, so dp of I forward slide. Just a second, let me correct the code. Okay. I think it was overflow. Runtime error, sigma integer overflow. Oh shit. If we have to write so we have to write this. We did not use integer, so I did not use unsigned wrong for the DPR there. So so see, we have not defined this. We cannot use integer, so we write unsigned long because the number of combination can become very large. Okay, so its int cannot store very big value, so overflow happens. So the code is right, logic is right, code also right. We have just int cannot hold large value, so for this we are going to use this. That's all.